So waves are nothing but the disturbance which is created at the steady state of a matter. So there are two types of waves. One is mechanical waves and another one is non-mechanical waves. In longitudinal waves we have rarefaction as well as compression, that is the particles are spread apart and there is a region of compression. The wave period is nothing but time during which the one complete cycle is performed. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 15 and chapter name is Waves. So in today's class, let us study regarding the introductory concept of this chapter, that is waves. So waves. So here, what is a wave? In your childhood, you have seen that a stone is thrown into a stagnant water, that is a water which is at stationary, steady matter. When you throw a pebble into a water, what happens to the silent water? It gives certain disturbance which is given in this diagram. So such kind of a image you have already seen in your daily life, and when you were in childhood you have performed such activities wherein you have observed that. Those time you were not observing each and everything, whereas this time when the chapter exists you can get to know certain examples. So here, wave is nothing but the disturbance which is created in a medium. So waves are nothing but the disturbance which is created at the steady state of a matter. So here, for example, you can consider dropping of pebbles to a silent water, as well as the waves. Here we study regarding light waves and sound waves. So light waves and sound waves are propagating. So light waves, when it propagates, what happens to the light waves? It reaches our eye. How does it reaches our eye? It reaches by traveling through certain medium. Okay. Similarly, sound waves. Sound has got certain waves and it travels through space and we hear the sound. The sound is audible to us. So that is all because of medium which is present between the initial and final materials. Okay. So that is all about the waves. So what is waves? Waves are the disturbance which is created in the medium such that we can see waves or we can hear sound waves. These are all about waves. So what are the types of waves? So there are two types of waves. One is mechanical waves and another one is non-mechanical waves. So what are the difference between mechanical waves and non-mechanical waves? So here in this case, in mechanical waves, the wave requires a medium for propagation. Suppose if you consider a vacuum condition where there is no presence of any sort of medium, it is completely zero. Suppose the particles which is present within the closed container is completely zero, that is the container is in the state of vacuum. What happens when there is a sound which is produced inside the vacuum? We can't hear. It becomes feeble. The sound becomes very, very feeble. That is because of there is no presence of medium for the sound waves to travel. So for something to travel, it needs a wave. That is, for a sound wave, for the wave to travel, it requires certain medium. So whenever we talk, what happens whenever we talk? There is a audio which comes out of your mouth. So here, the audio is nothing but the voice. Your voice is heard by some other person and some other person hears voice because from me to any other person there is certain distance and that certain distance is covered up with certain medium and that medium is nothing but this atmosphere, gaseous states. So these gas molecules are having certain particles within it which are considered to be a medium. So this invisible medium carries our audio frequencies to the next person, because of which we say we require medium. So here in this case, mechanical waves are the waves which requires material medium for its propagation, that is material medium for its movement. Next is non-mechanical waves. So what is meant by non-mechanical waves? A contrary to the mechanical wave, that is the wave which does not require any sort of medium for their propagation. So for mechanical waves, you have an example of sound waves or light waves, and you will have, for non-mechanical waves, you have an example of electromagnetic magnetic waves. So this non-mechanical waves is also known as electromagnetic waves. Why? Because of the waves which does not require material medium for its propagation can be ultraviolet rays, radio waves, microwaves, visible light, all these infrared radiations, all these comes under electromagnetic waves. So that's all about your mechanical waves and non-mechanical waves. So we study the sound waves as well as light waves concept under which kind of a wave? It is a mechanical wave. So mechanical wave is further divided into transverse wave and longitudinal wave. So what is this transverse wave as well as longitudinal wave? Let us study now. That is transverse wave. For it, I can give an example of light waves. Light waves are an example, a clear example for a transverse waves. Why and how? So here the particles of the medium, we talk about not the particles of the light, it is particles of the medium through which the light propagates. So for example, here there is a light which burns and the propagation is like nothing but there is a medium which is present over there. That medium is available for the scattering effect of the light. So that medium is the one wherein the propagation of light takes place, and the propagation depends upon type of the medium through which the light passes. So here in this case that the particles of the medium oscillate. So in this medium there is a presence of tiny particles which is necessary for the light to travel. So you have got a wave. When it is a wave, we show the wave nature in this manner. So this is a wave. For a transverse wave, we have got, this is the medium through which the wave is traveling. When this is a medium for a wave to travel, there are presence of particles, and suppose if I consider one particle over here, this particle is vibrating, that is it is oscillating at the mean position which is perpendicular, which makes a perpendicular direction, that is at 90 degree, it makes a perpendicular direction for the mean position, for this position. So particles of the medium oscillate about to their mean position, and that oscillation is nothing but perpendicular to the direction of propagation, which is known as transverse wave. So what is transverse waves? If the particle of what? If the particle of medium is making an oscillation which is perpendicular to the direction of its movement, that is direction of its propagation, such kind of a wave is said to be a transverse wave. And the example for transverse wave is nothing but light waves. Now next let us go to longitudinal waves. So first we study regarding mechanical waves, non-mechanical waves. Under mechanical waves you have got two branches. One is transverse wave, the other one is longitudinal waves. So here in this case in longitudinal waves, we can give an example by looking at this image as sound waves. Sound waves are the example for longitudinal waves. So in this concept, the same thing we are studying regarding the particles of the medium. So in transverse waves, the particles of the medium are oscillating perpendicular to the direction of propagation, wherein in longitudinal waves, the particles which is present in the medium is moving parallel to the direction of propagation. So it's just movement is just go, push the other particles, get back, again push the other particles and get back. So pushing the other particles which has gained energy, the energy is passed on to the successive particles. Okay, so that is what it is. A wave in which the particles of the medium oscillate about their mean position along the direction, that is how the direction of the propagation takes place. Similarly, the particles are oscillating. It just, if the set of particles are present over here, which is under motion, and other set of the particles are silent in a stationary position, the energy gained by this set of particles is transferred to the other set of particles which is stationary, and it keeps on transferring its energy. So this successive transferring of energy is obtained over here by rarefaction as well as compression. So these two are the concepts which comes under your longitudinal waves. In longitudinal waves, we have rarefaction as well as compression. That is, the particles are spread apart and there is a region of compression. Again, it's spreading apart, again region of compression during its movement. Easy example what you can give is a spring. You can see if the spring is fixed at one side, if you just pull the spring and leave it, what happens? It just moves in this way. That is compression and rarefaction you can see in terms of a spring. In longitudinal waves, you see rarefaction as well as compression. Similarly, in case of transverse wave, you see crest as well as trough. The portion of a wave where it raised higher, that portion is known as crest. The portion of a wave where it is showing a valley point, that is this part, a valley point, a depressed curve, there that point is the maximum depressed part is known as a trough. So here we have got crest and trough in case of transverse wave, and we have got compression and rarefaction in case of longitudinal wave. So having the concept of this transverse wave and longitudinal wave, further we are dealing with the wave that is nothing but a transverse wave, that is said to be a light wave. So here, let us study regarding the basic concepts of this transverse wave. So here, we have got amplitude, wave period, likewise you have got your wave frequency, phase, velocity as well as wavelength. So here, first of all, let us deal with amplitude, whose symbol is represented by A. So what is this amplitude A? Amplitude A is nothing but the altitude, that is the height of the wave from its mean position. So what is mean position? This x-axis is said to be a mean position, wherein this is y-axis. The black line over here represents the mean position or the equilibrium position, which corresponds to 0, the value 0. So when there is a effect of a wave here, we consider a height. The height of the wave is represented by A, which is said to be the amplitude. Whereas when you come to this wave period, what is this wave period? It is the period wherein the complete one cycle of the wave is set up. So complete one cycle of the wave means, suppose if you consider a wave from here, this point to this point. If this is a wire which is pulled up in the form of a wave, if I just take the wire and encircle it, it gives me a complete circle. That means this part is situated here, which I am bending like a wave, wherein this part, if I take that, the part 2, if this is 1 and this is 2, and from 1 to 2, if I just take off the wave, if I disturb this wave nature, if I just encircle, it gives me a complete one circle. So it is, the wave period is nothing but time during which the one complete cycle is performed. Okay, so that is represented by T, capital letter T gives you the time period from this position to this position. So the representation of wave period is nothing but T. So next let us go to the basic concepts of the transverse wave. Again, under that it is wave frequency as well as phase. So what is this wave frequency, which is represented by a symbol known as nu? Nu is the representation of a frequency. So what is this wave frequency? Number of wave which is set up in a medium for 1 second. For 1 second, how many waves are set up in a medium? That gives you regarding the wave frequency. So here the wave frequency, as I told you, it is determined by nu. And how is wave frequency given? It is always told that wave frequency is the reciprocal of, that is inversely proportional to the time period, which is known as a wave period. So frequency is reciprocal of wave period. Next is phase. So what is this phase? Phase of a vibrating particle at any instant indicates the state of vibration. Okay, so at any phase, if the particle is possessing certain phase during the propagation of a wave, it determines the state of vibration of the particle which is in the medium. Phase is represented by this term known as xi. So here, if this is your y-axis and this is your x-axis, here you have got x is the one which is told as mean position or a equilibrium position, which have the value of origin, that is O. It is at initial condition at this line. So you have got this, if this is a transverse wave, these parts are your crest and the lower valley points are called as trough. So here phase, when it comes to phase, it is the value which is present between the waves. So it will be pi by 2. So pi by 2 plus pi by 2 gives you pi, and pi plus pi by 2 gives you 3 pi by 2. Likewise, it goes on. So what is the value of pi? Pi is nothing but 180 degree divided by 2. Pi by 2 gives the value of 90 degree. So that is all about your phase values. So now you have got, after phase value, it is wavelength as well as wave velocity. So wavelength is nothing but, it is determined by a lambda, symbol called as lambda. So here, what is meant by a wavelength? If again this is a wave which consists of y-axis, here it is x-axis, this black line indicates your equilibrium or a mean position, then the wavelength is given by, it is a distance between two consecutive crests. So this is two crests, distance between them is nothing but wavelength. Or it can also be called as, if this is crest, these are the down which is giving a valley points are said to be a trough. It is defined as the distance between two successive consecutive trough is said to be the wavelength. So it can be defined as the successive distance between two consecutive crests, or else the two troughs are said to be the wavelength of a wave. So here, wave velocity. What is meant by a wave velocity? Velocity is nothing but the distance which is traveling, the displacement taken by a particle with respect to a time. So the same thing is applied over here, the distance traveled by the wave in 1 second. So in 1 second, how much of the wave is traveled? That distance is given by this wave velocity. So distance traveled certain time at certain time interval gives you the speed of the wave, at what speed the wave is. So distance traveled by the wave in 1 second is given by wave velocity, which is given by v. Okay, so now these are the basic concept for us to know regarding the waves. These are the parts of the waves for us to study. Having these concepts, let us study regarding the relation between the wave velocity, wave frequency and wavelength of a wave. So when this is a case, here we have to consider a wave of wavelength said to be lambda and its frequency nu, which is propagating through a medium. Wave is said to be propagating through medium every time. So with a velocity v, so v is said to be the velocity. The wave velocity is the distance traveled by the wave in 1 second. It is the last definition whatever we had studied regarding the wave velocity. So the wave travels a distance which is equal to one wavelength in a time interval equal the wave period, that is wave period is nothing but t, and therefore what do we have? So we all know that velocity is equal to distance by time taken. So wave velocity is nothing but a wave velocity. Wave velocity is equal to, what is the distance calculated in the wave? It is nothing but the length, wavelength. So it can be given as wavelength divided by what is t? T is nothing but wave period. So we have got wavelength which is given by lambda and wave period is nothing but t. So wave velocity v is equal to lambda by t. And we know that lambda into 1 by t. If we split up, we get lambda into 1 by t. Let me split up and show you. It is lambda into 1 by t. So we know one relation, that is, we are checking about the velocity, frequency and wavelength. We got our velocity, we got our wavelength. Now we need a frequency. So how do you get that frequency? You know the relation that frequency is equal to inverse of, that is a reciprocal of the time, that is a wave period. So when this is a case, you can just give your 1 by t as nu, which is said to be frequency. Now you have got the velocity, frequency as well as the wavelength. So v is equal to nu and lambda. So where v is said to be velocity, this part, that is nu, is said to be frequency, and you have got your lambda which is said to be the wavelength. So this is the relation for you to study regarding relation between velocity, wave frequency as well as the wavelength. That's all about your introductory part of waves. So here in this today's class, we have studied introductory part of the waves, that is what is meant by waves, how many types of waves are present, the two types, that is mechanical, non-mechanical, under which we are studying, that is under mechanical wave we are studying about transverse wave and longitudinal waves, and some basic concepts of transverse waves. Having these basic concepts, we derived a certain relation, that is relation between wave velocity, wave frequency as well as its wavelength. So that's all for today. Have a good day. Thank you.